Awesome. All right. Good morning, everyone. Welcome to the SAGE Live November edition. Before we start, let me just briefly explain what SAGE is all about and how SAGE Live fits into the general SAGE journey. SAGE Journey is a program whose mission is to inspire and encourage students to explore STEM careers for their future. We do this by offering free summer camps, paid internships, professional growth sessions, and many opportunities to connect with professionals who care about you and your future. SAGE Live is part of the SAGE Journey. It's an online gathering of students who've attended summer camps and are curious about the next stages of their SAGE journey. It is also a time to reconnect with the SAGE volunteers. It's held monthly on Zoom between the months of August and May. And the topics covered are relevant to your journey, which is career related, such as designing your life, resume workshops. And we have exciting topics such as quantum computing, AI learning, and today we're going to hear from 4 different speakers with a variety of topics. So get hype. All right, we're going to start really quick with an introduction video that describes the science that we do at Los Alamos.
At the heart of everything we do at Los Alamos National Laboratory is science, pure and simple. Well, maybe not so simple. The diversity of scientific endeavor at Los Alamos is amazing. National security science requires basic research.
We have experts here from all over the world, and we also collaborate globally. This diversity of scientific thought has always been the laboratory's greatest strength.
The Manhattan Project brought together a large number of experts in various technical fields from all around the world to solve a very complex problem. Today, we rely even more on that level of expertise for certifying the safety of the nation's nuclear stockpile through very complex simulations on some of the world's most powerful supercomputers.
Computational simulations are vital to the work that we do here at the laboratory. There are many things that we're interested in that we can't actually test with a physical experiment. We need to use the best science and engineering that we have to protect the nation.
We're trying to solve problems through the pursuit of science with the hope that our science makes the world a better place. More than that, we can make it a brighter, a safer, a more stable place.
A national lab is always thinking about the biggest challenges that we have and how we come about solving those challenges.
Science here at Los Alamos is definitely not a one-person venture.
The collaborative nature of Los Alamos allows for experts in all fields of science to come together to solve big problems.
Problems that are too big for one person working in isolation to solve.
There's a lot of really good science here for a variety of global security, national security interests, because that's what needs to be done.
We like to leverage our science capabilities to inform our national security work, and then at the same time that national security work bolsters our science capability.
And because of that, we're able to work on new discoveries and different science that can't be done anywhere else.
Science is the ultimate exploration for knowledge. It's the way that we understand how the world around us works.
Science is curiosity, asking questions, developing solutions, so that we can actually have answers to mankind's biggest and most pressing problems.
The ability to work on complex problems, help solve them in the national interest, is one of the most rewarding things a scientist could ask for.
Our science is what prepares us to face the uncertainties of tomorrow. It allows us to achieve things that are right now only in people's dreams.
right, so let's get into the main event. Our first speaker today, oh, I should say that today we're going to hear from 4 speakers about STEM careers that don't require a PhD. And we've invited 4 engineers from Los Alamos. And so our first speaker today is Brittany Olette. Brittany is a structural engineer specializing in structural health monitoring, SHM, and composite structures. She is passionate in making sure structures are able to survive the loads applied to them, and methods and techniques to check for and monitor possible damage. She has a BS in structural engineering and a master's in structural engineering, and with an emphasis on structural health monitoring from the University of California, San Diego. She worked as an analyst supporting the James Webb Space Telescope, as a liaison engineer at General Atomics, aeronautical systems supporting the unmanned aerial vehicles or drones, Predator A, Predator B, C aircrafts. Brittany currently works in the Advanced Engineering Analysis Group at Los Alamos, and outside of engineering, Brittany loves painting, baking, cats, and raising her 2 daughters. So take it away, Brittany.
Hi, good morning. Nice to meet you all. Let me see if I can share my screen. Give me 1 second. All right. Does that look okay to everyone? Okay, let me.
Can you full screen it or presentation mode it?
I'll get there. Yeah, let's see here. There we go. Play from start.
Looks good.
Okay. All right. So here am I. Thank you so much for the introduction. So I'll get to it. So let's see. Let me move this out of the way. Okay. So I'm roughly a 2nd generation college student. My mom went to a local community college and got her associate's degree. My dad was a self-taught electrical engineer, so he did not go to college at all. He just read books and took things apart and maybe put them back together. And then for me, I studied at UC San Diego, structural engineering. I completed my bachelor's in 2009 and then went straight into industry with a bachelor's degree. And then 7 years later, I decided I wanted to get my master's. And so we moved to New Mexico and I started the master's program at Los Alamos National Laboratory. So I just wanted to highlight that, and that, education isn't necessarily like a one-shot thing. It can span your life, and you can take breaks and pauses. So I completed that in 2019, and now I'm an R&D engineer at Lano. I was born and raised in California in the Bay Area. So I know there's a lot of people from California here. So we still go back and visit family a lot. So I would say my homes are New Mexico and California. I visited the Stanford Linear Accelerator, went to a talk with my dad once. And so, yeah, like what was previously mentioned, I love art. I love painting, ceramics, pottery, everything. I love baking. I love my 2 cats, Evie and Mochi. The gray one is Mochi, and then the brown one in the bottom is Evie, and Evie's actually with me right now. So they're awesome. I've always loved cats. And then my family is in the photo on the top left. It's my husband and my 2 wonderful daughters, Carmen and Stella. So they keep me busy when I'm not doing engineering. Let's see if I can, there we go. Okay, so art and creativity, I think, led me to structural engineering. When I was little, let's see if I can, there we go. When I was little kid Brittany, I loved building. So I remember when I was little, it was just pillow forts, blanket forts, again, the ceramics, anything that I could do with my hands, making go-karts out of anything in the garage. I would bake with my mom, and then solder and woodwork with my dad. So in their free time, I got to, measure and do chemistry with my mom in the kitchen. And then my dad, being the electrical engineer, had a small lab in his home. And then I got to woodwork. So the photo of me right there is little Brittany with I think kind of like a heat gun. It basically burns wood. So I was doing just whatever designs I wanted in a scrap of wood. Luckily, it looks like I got those safety glasses on, which is good. So high school Brittany was interested in architecture. I did a couple reports in different architecture styles. Still love art and did ceramics in high school. And then I absolutely enjoyed all of my science classes that had experiment or lab component to it. So the biology, chemistry, and then physics. I enjoyed it a lot. My physics teacher had kind of an interesting sense of humor. So he would be talking about units and then how, if you're building a bridge and you're using inches but you design your bolts using millimeters, and then you've got this bus of kitties and puppies going across the bridge. Well, maybe that's not so good. So he used, humor to drive in his points. And then college. So I was like, okay, well, I'll just continue with physics. I really enjoyed it in high school. So I started with physics. I took a few classes and I was pretty much failing that last class. And I realized I needed to pivot. And my mom helped me find the structural engineering department. So I was able to go meet with the counselor there, and they were able to set me up to graduate and get all those classes made up. So that's kind of where I found structural engineering. It was kind of a blend of art, physics, and architecture. So everything that I was interested in kind of combined for that. Okay, so I have a question. Let me see if I can get people on the chat. There we go. My chat window is open. All right. For all of you, you guys can see my screens, right?
Yes.
Okay, thank you. So with these 4 images, what do you think structural engineers work on? Top one is hotels, bridges, aircraft, and D is satellites and telescopes. So feel free to answer in the chat if you have any ideas, and E is all of them. So let me know what you guys think. Oh my God, Marina Bay Sands, this is Joanna. Yeah, so it looks like a few answers are coming in. That's awesome. So yes, E is all of them. Yes, the top one is that hotel / mini city is the Marina Bay Sands. I think that's in Singapore, and it is gorgeous and probably an engineering feat where you've got hotel, and then on top is the I think there's a pool, and I'm sure there's some restaurants. And if you've seen pictures online or on Instagram, it's gorgeous. B is the yep. Okay, thank you. B is the San Francisco Oakland Bay Bridge. So I've been on this bridge. Yep. Anna, yes, a pool that high. It's pretty nuts. Yeah, so B is the bridge. It's a cable stay bridge, I believe, in the Bay Area. It's beautiful. I take that to go see my sister who lives in Oakland, and she's a geologist. And then the bottom 2 are actually structures that I've worked on. C is a UAV, and D is the James Webb Space Telescope. So yeah, I've been able to work on 2 of the 4. So structural engineering is not necessarily what you would think of civil structures. They can be, but you can also work on pretty much anything. Let's see. So next, let's see here. All right. So the day in the life of a structural engineer. So daily life, again, it depends on what kind of job you're doing. There's a lot of different opportunities within the structural engineering department, or sorry, within structural engineering. So the first job and the current job I'm doing now is an analyst, structural analyst. It's about 100% working from your desk on computers. When I was first hired at Los Alamos, I was a test engineer, and we were doing 50% computer work and then 50% in the lab. So you saw in the video earlier, there was people outside working on large structures. there's people inside in the lab, and I was able to do both of those. And then the liaison engineering role, which I held while working on the UAVs, which is letter C, that was about 75-25%. So a little bit a mix of both. And so there's kind of a job for whatever kind of daily environment that you would be interested in. Let's see. Let me move this chat. Tools in general, all these jobs require effective communication. So the way you can get ahead and be the best engineer is to work with others and develop those communication skills. General tools that we use throughout all of my jobs are Excel, PowerPoint, Word. Specific tools that I use, computer-aided design, CAD, which is kind of our design tool. Once you learn one, it's really easy to learn others. So don't get nervous about that. I use finite element analysis software, and that's specific to any analyst role. And then we also use a lot of coding. So MATLAB, Python, there's a lot of others, but those are some key ones that you use in university as well as industry. And then lastly, what I wish I knew when I was in high school. So comments to me when I was younger. I think I did this pretty well, but I would encourage, oh, that's a typo. Surround yourself with smart and good people. So I've always heard surround yourself with smart people, and that's definitely super beneficial. Kind of just brings up the average of everyone. They're going to be supportive of your education and all of your efforts. And then good people too. It's always important to have kind people that care about others and the community as well. One important thing that I would tell myself is even in hard or trying times of your studies and your career, there's always something to learn and something to take away from that experience to make you stronger. So I'm pretty sure all of the engineers and scientists in this have felt that, you know, oh my gosh, I'm failing, I'm never going to get this. Those things are not uncommon, and we just kind of have to, you know, surpass that and keep moving forward. And so one of my favorite quotes is from a children's book that I read to both my girls. It's called Rosie Revere Engineer. And the great Aunt Rose that used to work on the aircrafts would say, your brilliant first flop was a raging success. The only true failure can come if you quit. So keep working. If you think you're struggling, lean on your friends and your colleagues and your coworkers, and that'll help. And then also never stop being your dorky, silly, cat-loving self. You will find your people. So thank you.
Thank you. That was amazing. It's actually interesting that, you know, I use MATLAB and Python too. And so, you know, doing these skills, you can apply them to a whole bunch of different disciplines. So it's, anyway. All right. Does anyone have questions? Don't be shy. It's okay to ask questions about the cats.
Oh, good question from Adrian. She asked, what did you do on the James Webb Space Telescope? So as an analyst, we were a subcontractor, and we had the backplane of the telescope. So behind all of those beautiful hexagonal mirrors is the backplane structure, which keeps the mirrors in place, and it's the main structural component. They help open. Stow is the closed component, and deployed is when they're open. So we were doing the structural analysis on those, the backplane pretty much. And so we were able to take the geometry that was sent to us and what we call mesh it. So we basically discretize it. We model all of the components that are on there. So there's metals and adhesives, and then we run it through a solver, and we are able to look at the stresses and then report back to the customer. And then the cats. Evie, can you come here? Let me see if I can get her real quick.
I think Weldon also has a cat. Look at that.
Oh,
Oh, look at the cat people. Let me call my
Hey,
chihuahuas on
where are my cat
screen.
people? So cats have always been in my life, even when, I was kind of a shy younger girl. So these are my cats. I got them right after I graduated college. So Evie is 13 now, and then Mochi, I think he's hanging out with the girls upstairs. So Evie says hi.
and so how many different sections of the mirror on James Webb were there?
I don't know how many sections of the mirror. I know the back plane has the main structure, and then there's like 2 folding sections, and that's about it.
Yeah,
As
because
far
I
as
think
my
it's
knowledge on it.
something, I don't know, I'm trying to remember an image like 12 or whatever, but it's just, in case people didn't know that James Webb, when he shot it into space, it was all packed in. And then it got, I forget how far away, very far away, and it had to just open up out in space without someone like making sure it works really well. And so it just took a lot of work to be able to do that remotely, which is something that I always thought was really cool.
And withstanding unusual environments, you've got like crazy changes in temperature that all of those components have to withstand and work together and move.
Exactly.
It's an interesting problem.
Looks like Sierra had a question. What has been most challenging for you?
I would say my first job was, I guess, technically challenging. So it was, or sorry, not my first job. My first job at Lanel as a student, as a master's student, I was given a test engineering project that wasn't just specifically structural engineering. I did a little bit of analysis to make sure the structure wasn't going to like vibrate and move and break down during testing, but a lot of it was electronics. It was understanding how the lab worked and doing all of the like the safety and just production and getting all of your equipment from point A to B, and understanding all of the electronic hookups, what you need for your test equipment. So if you need water for your environmental chamber that you're using, you got to make sure that the water is available at the other site. And then if it's not, then you need to bring in some other equipment. And then of course, when you move that equipment, say it doesn't work properly, now you have to troubleshoot. So it's thinking on your feet. I would say it was most challenging, but I got to use a lot of my engineering background and the studies that I learned in university, along with other people to help out. So I would say that was most technically challenging. Yeah, all the jobs have been challenging in a good way. There's never one solution, which is good, but the solution is unknown. So you get to use your creativity.
And is that your art on the wall behind you?
No, it is not. It's actually from my mother-in-law, but it's very Santa Fe, and I think it fits into the kind of the environment here. So
yeah, it's beautiful.
Thanks.
Okay, we're going to go on to our next speaker, but there will be time after all 4 speakers to ask additional questions. So if something pops up, keep it in mind. Thank you, Brittany.
Thank you.
All right, our second speaker is Megan Wheeler. Megan grew up in Nambe, New Mexico, and attended Pewaukee Valley High School. She studied chemistry and mechanical engineering at Northern Arizona University and graduated with her bachelor's in 2019. After completing undergraduate studies, Megan went to the Colorado School of Mines and graduated with her master's in metallurgical and materials engineering in 2021. Megan has been working at Los Alamos since 2015 and has been a process engineer at Lanel for just about a year now. So Megan, take it away.
It's nice to meet everyone virtually. I'm going to go ahead and share my screen.
I want to add that Megan has also been volunteering for the summer physics camp for young women for many years. So she's giving back to the community what was offered to her some time ago. So thank you, Megan, for what you do.
Yeah, of course. I love volunteering and being involved, so it's been a joy. So I wanted to talk to everyone today about my journey to becoming a process engineer at Los Alamos National Lab. So how did I get into process engineering? It's been a journey for sure. So I grew up in Nambe, like Andrea has mentioned, and I attended Poaka Valley High School and Poaka Valley Schools until I graduated high school. And growing up in the Valley, I was able to obtain a scholarship from Los Alamos National Lab. And this really pushed me to get an internship at Lanel. So I've been at Lanel since I graduated high school. So it's been, I think I'm coming up on 7 years now at the labs. This scholarship really pushed me to get the internship at Lanel. I called every day trying to get an internship. I really bugged them until they placed me into a group. So I really pushed hard for that internship. And in addition to that, I'm a first gen student. So I was first gen at the labs. Neither of my parents worked at the labs. None of my grandparents did either. So first gen at labs. And also I was the first in my family to attend undergrad and get my master's. So first, lots of firsts for me all around. And I completed my undergrad at NAU. And I kind of picked chemistry at random. So I didn't do super great at chemistry when I was in high school, which was a little surprising going into chemistry for my undergrad. But it seemed like a fun degree. I loved the professors, and so I settled on chemistry, and I chose mechanical engineering also kind of at random. I distinctly remember driving home from Flagstaff for Thanksgiving, and I got a call from my advisor saying, hey, you're taking too many math classes next semester. You need to either be a math major or focus on something that is more related to math. And so I said, well, what are my options? And he said, well, math or engineering, pick one. And so I picked mechanical engineering and actually fell in love with it ever since. So after graduating with my undergrad, I was encouraged to pursue my master's by multiple mentors at Lanel. And so I applied for a GEM fellowship and I was awarded the fellowship. And I went to Colorado School of Mines and earned my degree in metallurgical and materials engineering. After I graduated, I started as a full-time process engineer at Lanel in the foundry, and I'll talk a little bit about that next. So a little bit about the foundry. I know it's metallurgical and materials engineering is kind of a mouthful, and I didn't really know what it was before I started working in the foundry, so I'll explain it a little bit. Metallurgy is the study of metals and materials. So basically, what we do in the foundry is we alloy materials, we alloy metals to fit a specific purpose, right? So everything that people use, right, like your phones, laptops, computers, they're typically made out of some sort of metal, right? Or they have components that have metal in them. And so what we do is we alloy those metals to fit specific purposes for whatever our customer wants, right? So you can kind of see some cool pictures. If you all want to take some guesses on if you see anything wrong with the two pictures that I'm in, there's kind of a big thing that's wrong in those pictures if you could pick it out. Yeah, there should be an award, but I don't know. If anyone can guess, put it in the chat. Oh shoot, I went back, sorry. Yes, safety glasses, great job. That's actually my lead tech. My lead technician was not wearing his safety glasses. So So shame on him. We did talk to him about it, but yes, definitely wear your safety glasses. Safety is important. But so how we start our day in the Foundry, we start with a pre-job. So before we go into any job, we have to discuss the job before and say, what are we doing? What goals do we hope to accomplish? Is everyone going to be acting safely? Stuff like that. So I do half hands-on work, half data analysis. So the cool pictures you see there, that's half of my day where I'm processing, I'm melting metal, I'm in the back with the technicians, I'm working in those cool yellow jumpsuits. But the other half of my day, I also spend trying to understand how I can optimize my process, how I can make it run faster, looking through data, pursuing maintenance of my equipment, because it is really important to make sure that your equipment or my equipment runs properly and smoothly. So that's a little bit about my day. And those pictures on the bottom left, those are melted plutonium metal. So now you guys can say that you all have seen melted plutonium metal. Pretty cool. All right, so going into a little bit about my inspiration, my family has always like really pushed me to pursue my dreams, even if they didn't know what they were. I think my family still gets a little confused on what I do, what metallurgy is and stuff like that. So just having them support me no matter what, they've always pushed me to do whatever makes me happy and excited. And in addition to that, I've had a ton of excellent women role models in the field of STEM. So just a few are shown here. And I wanted to honorably mention a couple great male engineers that have pushed me as well. Both of which were excellent in helping me decide what career path I wanted to go down. So my mentors, Alonso and Bill, have really pushed me into like doing the best that I can, helping me decide on a career path. Bill was the one that actually pushed me into going into metallurgy. So lots of great help from them. But so the bottom left corner, the woman circled she was my undergrad research advisor. And she really pushed me into getting my master's. And she was super supportive and helpful throughout the whole way. And Jerry Freer, the figure 11 picture, she was the one that actually told me about the GEM fellowship. And I can talk a little bit more about that in a bit, because I know there was a question on it. But basically a GEM fellowship is graduate education for minority students. So GEM helps fund students that want to pursue a master's degree, minority students that want to pursue a master's, and they'll pair you up with an industry sponsor where you can do an internship. I already had LANL, so I was able to complete my internship with LANL, and then they pair you with the school and you get to go to school and do an internship for free. So you don't have to pay for anything, and you actually get decent money to go to school. So that was answering what a GEM fellowship was. Yeah, so a little bit of tips and advice, stuff that I wish I would have known. Explore your interests early. So looking back, I wish I could have had a little bit more time to develop my skills and realize what I actually enjoy. Academically, because like I said, I think I picked a lot of things at random and they worked out for the best, but explore your interests early. Get into those things that you have even just a little bit of interest in, or you don't think you'll enjoy, or you just want to look into more. Check it out, try it. Make connections. So networking really helps when you start to build your career. Participate in those outreach events like the summer physics camp for young women. You'll build a strong network of people that support you and your goals, and they can help you out later on in your career. And go to the school that you enjoy. So I picked NAU also very randomly. I got accepted without realizing that I applied. It was very random. I really don't know what happened. I just got an acceptance letter in the mail and I was like, this is very strange. So I went and I checked it out and I loved the school. I loved the area and I went for it. So you don't have to go to a big fancy school. I enjoyed myself. I made a lot of connections that I wouldn't trade. And the experience of everything really helped get me to where I am right now. So yeah, that's a little bit of my advice. And I do have a dog. He's pictured here. He's sleeping on my bed right now. Otherwise, I would show you all him. But yeah.
Awesome. Thank you. Yeah, and I think it's making connections is a really good point to bring up. And I always also like to tell people to, nurture and maintain those connections. Like, I still am in touch with my 8th grade science teacher. She's fantastic. And she's helped me with some outreach stuff back where I grew up. So you never know when the connection is going to come up. And so, they like to get a email every once in a while about how you're doing your network. Okay, so are there any questions? Feel free to type in chat or raise your hand. Don't be shy. Well, while we were preparing for this, Megan was showing us her tattoo. Can you show us your tattoo?
Sure thing. I also have a chemistry one that's a little bit on the nerdier side of things too. But yeah, so I just got all this work done. So if anyone tells you that you can't have a job with tattoos, don't believe them. You can, I promise.
And then the chemistry one. Yeah.
Oh, isn't she nerdy?
Can you explain it? I don't get it.
It's adrenaline.
Yes. We had the volunteer at the summer physics camp that had I think it was the electromagnetism equations in her. Do you remember, Andrea?
The Maxwell equations.
Maxwell equations, yeah, in her arms as well. It was so cool.
Megan, are you planning on being involved in the camp again next summer?
Yeah.
Yeah. Okay, well, like I said, we got one more. What's the most satisfying part of your job?
That's a great question. So I really love being back in the processing area. That's probably the most satisfying part is when we finish operations for the day and I get to walk out with my techs and say, hey, we did such a good job. I love working in that team setting and working towards a common goal. It's really satisfying.
All right, thank you, Megan. We are going to have time for Q&A again a little later on. So if you get questions, we'll give an opportunity to ask them. And so we're going to take we're going to have a quick little break and not a you get to leave break. So thanks for the questions. And I guess now it's my turn and I get to ask you some questions. So please put the answers in chat. So the first question is I've been told the official question of New Mexico. We're like the only state that has an official question. It's very important. The question is, which chili peppers do you prefer, red or green? And Christmas is an option. All right, I'm seeing some Christmas. Oh no, not the red hot chili peppers. All three. Oh man, we're getting, pretty good representation of all of them. I personally like green.
You need to define Christmas, because in New Mexico we know what Christmas is, but
That's
maybe
true.
our Californian or Tennessee folks don't know what we're talking about.
Yeah, Christmas is when you have both red and green chili together. Yeah, if you visit New Mexico, for those who aren't here, definitely try the chili. Okay, so another question. What superpower do you wish you had? Parenting. Yeah, parenting's hard. Extra sleep. Yeah. Need to add an extra couple hours to the day. Have money when someone talks to me.
Yeah, Celine needs to explain that. What does that mean, Celine? Ooh, teleportation.
Yeah, I've been watching a lot of Star Trek lately, so I get the teleportation.
A money generator, she says.
Someone
Oh,
talks, you're like ding 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 ding.
The engineering challenge. I want to be part of that.
All A's, yeah. Although, like we've been hearing from our speakers, like you don't have to be straight A person at like a super prestigious school to have an amazing job and be happy. And so, it's good to go for A's, but grades aren't everything. Actually, I like to tell people that when I was an undergrad, I was not an A student, but I did a lot of research, and research is very different from classroom work because you're answering questions that don't have an answer. Like there's no answer key, there's no answer in the back of the book. And so that requires creativity and teamwork, and it's super fun. I loved research way more than I liked classroom work. Anyway, oh, to fly, yeah. Multitasking, good answers. All right, so I've got one more question before we move on to our third speaker. And I'm just curious, before today, had you ever met a woman engineer? Ah, that's awesome. I'm so glad you guys, that's great.
I must admit that before I started organizing the summer physics camp for young women, I had never met a woman engineer. And I was very happy when I was a project lead to be able to hire women engineers. And it adds, when you work with a diverse group, it adds so much better brainstorming than when it's a mono, everybody came from the same school and things the same way. When you had people that came from all over, and diversity, it just makes the creativity process much better. And creativity is problem solving at the end of the day, right? So we get better when we all pitch in.
All right, well, our third speaker this morning is Maria Sanchez Barrueta. And Maria is an electrical engineer specializing in high power radio frequency amplifiers for their use in particle accelerators, which make things go fast. And she has a bachelor's in electrical and mechanical engineering from the Public University of Navarra, Spain, and a master's in electrical engineering, specifically high power electronics, from Oh my, I can't speak French. Enseeeicht. I will ask Maria to pronounce that for me in a second. She worked at CERN, which is as a engineering fellow developing a test stand for a novel high power amplifier and supporting a pre-accelerator. And so CERN is where they discovered the Higgs boson by smashing protons together, in case you didn't know. She currently works at the Los Alamos Neutron Science Center, or LANCE, supporting the accelerator and its upgrades. So Maria, go for it.
Hi, everybody. So as I just said, my name is Maria Sánchez Barrueta, and just like a little bit introduction. My sense of humor, very European-like, tends to, when somebody tells me, do something and it's not necessarily technical, the previous speakers, amazing. They chose to go serious. I chose to go funny just because that's just how I work. So let me just give you a little bit of intro here. So yeah, like was just said, my name is Maria Sánchez Barrueta. I am a high power radio frequency engineer. That's the definition in the US. And when I'm not at work, I like spending time with my girlfriend, who's over there. I see her over there, Sierra, and her pit bull, and watching anime and playing video games. And so my dad was an electrical engineer, and somehow, through a very, very weird series of coincidences, I ended up in the exact same field as him, which I told him I would never do. So here we are. So just as something to let me share. Yeah. So this is Google Maps on Friday telling me how far I was from home. So you can see now, right now, I'm right in the somewhere center south of the United States. And about 4 years ago, I was in all the way over the Atlantic in Switzerland, in Geneva, where the Center for the European Nuclear Research is, CERN, which is a particle accelerator. Just a little bit before that, I was somewhere in southern France going through my master's program, and it's pronounced like N7 in French. It's N7. I know, it's like the actual letters, nonsensical. And then just a little bit before that, I was in the north of Spain. So that's where Waldo/Maria is. And that's my hometown, where I studied my bachelor's degree, which is in mechanical/electrical engineering. Will come up again. So mechanical/electrical, remember that. So, and now I am all the way over working at LANL, but specifically at Los Alamos Neutron Science Center, which is another accelerator, which I like to say I make things go fast, essentially. So here we are. So north of Spain, where I am from, and here's going to be the little bit of interaction here. Let me see if I can make myself see the chat, just so that I can see the answers that people give. So where I'm from, something happens which is decently famous. So let's see if anybody knows what that is and where it happens. Any guesses? Do you guys see when I do that? Unfortunately, I didn't figure out how to do the chat. Super easy. Forgive me. So where I'm from, that happens. Anybody know? Barcelona, not. Sorry?
No, I was just going to say Barcelona from the chat, but you can read it. So.
No,
yeah, Barcelona.
I'm from Barcelona. We are not that
exactly.
crazy.
Careful here. no, that is not Barcelona. That is Pamplona, Spain. Nobody can guess what that is. Like, look at the animals. The animals running. That's as much of a hint as you're gonna get. Those are bulls. No, running. No, it's not Madrid. So that is Pamplona, Spain. That's the running of the bulls, and that's like the festival that occurs for a week, which is San Fermin in Pamplona. So, by the way, there's, the biggest town in New Mexico is Albuquerque. So there's something that people from Albuquerque and people from Pamplona share. And I'm not even going to ask for you to guess because it's kind of a wild thing, but here we go. We are haunted. We are forever haunted with this notion that the only thing that people know about us and from where we came from is a singular thing. In the case of Pamplona, this is it. In the case of Albuquerque, this is it. So just like Albuquerque is not just Breaking Bad, Pamplona is not just San Fermin. So if you, give me, I don't know why that happened. If you care to take a look, this is Pamplona. And that is, up top, cathedral, that is the promenade of the castle, La Vuelta del Castillo. Down on your left, that's the plaza of the castle, La Plaza del Castillo, and that's the city hall on down right. So all of these things are Pamplona, and so now if you ever meet somebody from Pamplona, don't tell them necessarily just about the running of the bulls. Tell them we love to name places after castles for some reason. So other than that, also, Albuquerque is not just Breaking Bad, it's all of these things. And this is just taken from basic tourism in Albuquerque. All of these things are Albuquerque. So let me go forth from there and go, anybody care to venture where this is? I've also been here, but just as a, where is this? Hint, there's like some sort of anime type of look to it. Anybody care to venture? I guess. A park. It is a park. You're very right. It's a park. No? Japan? Good guess, but gotcha. That's also Pamplona. Our sister cities in Japan, it's called Yamaguchi. We have a park that is a Japanese park. So specifically as to what is electrical engineering, because it's a wild profession involving everything and nothing, right? So what is electrical engineering? For me, electrical engineering is a variety of things. One of it is I went to school in different places and worked in different places. So the language that I used changed with the country that I was going to. And by the way, there's a fish in there. There's a word that is mistranslated, virtual cookie, to anybody that can tell me which one it is. So yeah, and engineering, electrical engineering in Spanish, electrical engineering in French, electrical engineering in English, all of these things are engineering to me. This is the language that I've used for years, and it goes back and forth and it changes. So yes, it's bias. It's biasing a transistor or polarización de un transistor. Completely different word for technically the same idea. But as you can see at the bottom, transistor, all across the board. Also, just help you out. The fish is Champs-Élysées, just because it's like the Elysian fields. I just put it in there. So again, as to what is electrical engineering. Anybody tell me if this is electrical engineering to them? And as you can see, it's like a bunch of ICs and in a PCB, and there's Arduino on one side, there's a Raspberry Pi on the other one, there's a bunch of through-hole components. Is this electrical engineering to you? Well, maybe it is, but what about this? Is this electrical engineering to you? You've seen these things. They're all over the place when you go on the road. You know, on the bottom left, it's like 400 kV lines, the ones that go cross country. Then there's the ones that we're more familiar with, which are like the lower voltage that come near our houses. Up top, there's a big transformer, which like you've seen driving through the road and you're like, what is that? That's like a big transformer. And also the one up top on the right, it's also a thing that you've seen kind of around. You've seen it outside your houses. There's one, I can guarantee it. So props to anybody that can tell me what that is and if they've seen it around their house. Otherwise, look for it. I can guarantee you that it's there. And you know, the way that we more often interact with these things is through the plugs. This is the power that we feed to all of our electronics. Is this electrical engineering to you? I asked. Nice. That is electrical engineering. All of it is electrical engineering. But specifically, what is electrical engineering to me? This is electrical engineering to me. All of these are very weird things, but they're all like, they all form part of one singular thing, which is these are high power radio frequency amplifiers. And they do different things. They operate in different applications, but two of these are in your house right now, and you use them every day. Guesses? Anybody? It's a slightly different form of one of them, but two of these are in your house. I can guarantee it. It does look like a lobster. It's funny. I picked it specifically because it looked funny. No, anybody? Ooh, microwave oven, TV. Not wrong at all. Microwave oven, TV. The heat water pump thing. It does look like a heat water pump thing. They do look like that. It's not. It's not that one. Let me just like cut to the answer. It's these two. The little thing on the top left is a magnetron. That's what's inside your microwave oven, and that's what provides power to it. And the up right image is a solid state amplifier. And smaller versions of these are all over the place. The most common place that people know it is you know, in their Wi-Fi, their modem/router. But it's also, one of those is in your phone. It's a smaller version of that. They're in the antennas on the street, amplifying the signals that come like right now to your computer. So all of these are electrical engineering, and we like interact with it all the time. So also, this is electrical engineering, and specifically, this is electrical engineering to me. You know, contrary to what science fiction usually has you believe, where there's one very smart person in the movie and suddenly somebody comes up to them and they just instantaneously come up with the answer or code in whatever it is that they need to. That's not how it really happens. There's like teams of people who discuss every day what the best path forward is, what the options are, what they need to do to get things done better. And that's most of my day. It's like going to meetings, discussing with people what the interactions of different things are and how we can make them better. Other parts of my day are staring at oscilloscopes with these like wavy things and trying to analyze whether signals look right or wrong, or looking at schematics, producing them. Forgive me. So that we can take a look at components, how they're supposed to operate, or network analyzers, which are like these really cool scope-looking thingies, or multimeters, which you might have handled already. Those are all of the tools that I use in my daily life. what I like most about my job is that it changes day to day. It's never the same. I don't do the same thing 2 days in a row. And that's like the best part of it. So now you heard from some mechanical engineers before, and I'm partly a mechanical engineer as well. Like if I go back to Spain, I technically could work as a mechanical engineer. However, why did I pick this path? So let me tell you why I hate mechanical engineers a little bit. They're fantastic. They're people who create cars and bridges and planes. You've already seen the amazing things. Like they work with metallurgy and produce like the things that we use every day. It's an amazing field. However, for my entire life, I've had to present with mechanical engineers, and what they present is akin to magic. It's like these shapes which they make, and they have like an actual thing that they like hand over to you, and it has weight and its size, and it's like all of these things. Their presentations are amazing. If I do my job to the best of my ability, if I just kill it one day and like solve all the problems in engineering, the best I can hope for, the most amazing thing I can hope for is, oh, darn it. Sorry. It's not there. Forgive me. One sec. I'm almost there. Darn it.
Anyone has a guess? Anyone has a guess of what's?
Yes,
what
please.
I think it's a diagram.
It's a diagram? You think so?
Yeah. A light bulb going on. A description.
A description. That's a good. It's an interesting notion. It is not. It's not. It was so much better with the thing. It's a waveform. It's just a thing going around the screen. It's a waveform. It's just like a thing that like goes through a scope, and it's like, oh, it's great. I was gonna put like a little GIF of a hard monitor, because that's what we usually think of, and that was like a great suggestion by my girlfriend. But that's it. I do my job right, and that's it. That's all I can show. Imagine putting that in a presentation next to a mechanical engineer who's just like, oh, I do all of these pieces. Look what I made. So I love mechanical engineering. I hate it a little bit because they just like have so much cooler stuff to show.
You're just jealous. Come on, admit it.
I am. Totally. There's just absolutely no discussion there. But why then would I pick mechanical engineering if that's it, right? Oh, sorry, electrical engineering. It's because there's like this paragraph on the first chapter of every electrical engineering book, no matter which one you choose. It's like, it says, well, what I'm trying here is to make it obvious how this works, because for most people and they mention it's an art, it's a craft, it's black magic on the most extreme of cases. They mention that it's this thing that it's like so incomprehensible. How can you do it? And why is it like that, right? Why is it like that? It's because like everything in electricity is explainable by a single principle of physics, but it all happens at once. So it's all combined into this thing that it's so difficult to pick apart and discern and find out what it is that you're actually dealing with. And this makes it so that it's weird. It's like amazingly weird, and you're trying to essentially like, mechanical engineers, they build things. We're trying to route electricity, figure out to where do we want it, in what quantity and in which form, and that is what I love about electrical engineering. It's that it's weird and it's indiscernible. It just suits me. And my last slide, which apparently I lost somewhere, but was going to be about what I wish I would have known as in high school. And there's like a couple of things. One, it's that it happens a lot to me in engineering that people just continuously like say something like and forgive me for my description, this is my Spanish translation. It's not that engineers are not very smart, it's that engineers are not necessarily the most like the smartest or like cleverest people. It's the people who love engineering the most and are the most tenacious to accomplish. And you've heard it before. It's not just about, oh, you're the smartest person, therefore you chose engineering. No, it's that you wanted it enough and you loved it enough to just continue and persist. It isn't a competition. You don't have to get ahead. And kindness. Just be nice to people. Engineers, sometimes we become hard a little bit, and it's not necessary, it's not useful, it's not good. Just be nice to everyone. Empathy, compassion, they are great. They allow you to like gauge how people are and what their mood is and have conversations that flow better and accomplish things easier. And engineering, and you've heard it as well before, it's as anything in life, it's about connections. Don't be afraid to chat and mingle and make connections that either will become useful or you'll become useful to them. It all comes back kind of in a roll backwards. So just, these are the things that I thought would be useful to me, at least. That's it. Thank you for listening.
Yeah, thank you so much, Maria. Yeah, I will, emphasize again, yeah, that kindness is a really good piece of advice. Yeah, because I was actually just having this conversation with someone that, if you're a bit of a jerk about it, people aren't usually going to listen to you or implement your ideas. So be nice. All right, so we're going to just jump into our fourth speaker, and we'll do Q&A for both after. And so our final speaker this morning is Reina Ledoux. Reina is a 20-year-old veteran of Los Alamos National Lab, supporting precision machining and dimensional inspection of unique manufacturing facilities. She is recognized within the meteorology community as a subject matter expert in coordinate measuring machine, CMM programming, capability, NIST traceability, controller communications, and maintainability. She has a BS in a bachelor's in mechanical engineering from the University of New Mexico and a master's in mechanical engineering from Arizona State University. She is a native New Mexican going back many generations. She's a graduate of Espanola Valley High School and is passionate about encouraging young women with similar backgrounds to pursue education and careers in STEM. After the loss of her beloved husband to ALS, John Ledoux, she is focused on raising their two teenage children and honoring his legacy of supporting the education of New Mexico youth. So let's give it up for Reina. Go ahead, you have the floor.
Hi everyone, can you hear me okay?
Yes.
Okay, good. I get worried. I live in a rural area and sometimes not everything works the way it should. But okay, we can go to the next slide. Like my bio said, I'm a native New Mexican going back many generations. I grew up in the small community of Espanola in a little village called Cuarteles. That's where my dad was born. When I was a kid, almost everyone I knew was similar to me. Spanish-speaking descent, honest, hardworking in the trades or in education. and all of us surrounded by extended family, you know, being raised by grandmas and grandpas and tios and tias, and it was all kind of the same type of folks that I was surrounded by. The laboratory being just about 30 minutes away from my home did open doors to many of us in the Valley, including my parents. My dad worked at the laboratory as a mechanical designer, and my mother always valued education. So I always knew that I was going to attend university. However, even after high school graduation and starting at the University of New Mexico, I was unsure of what I wanted to study. I had no idea, you know, what I wanted to be. And sometimes at the time I would punish myself. Now I think, who really knows what they want to be when they're 17 or 18? But there were the obvious suspects, you know, was I going to be a doctor, a lawyer, an engineer? But I spent the first year kind of exploring my options. I was always very good at math, but I knew I wasn't going to want to be a mathematician. So it was like, engineering it is, right? If I take myself back to those high school days, it's actually very unexpected that I ended up being an engineer. But it's been a choice that's provided a very exciting and challenging career that's taken me to places that I never thought I would go, allowed me to sit at tables with brilliant individuals, and allowed me to provide for my family. So I am the first in my family to earn a 4-year degree, and that's a BS in mechanical engineering from UNM. And then I also am the first to earn an advanced degree, which is an MS mechanical engineering from ASU. ASU was my dream school. So right out of high school was unattainable, just financially, just wasn't going to happen. But, you know, going to my state school, when I was ready to go on to ASU, everything was paid for. You know, being female, being Hispanic and American, wanting to go into an advanced STEM degree, really, I could have gone to any school I wanted to go to earn my degree and probably not have to pay for anything. So first and foremost, on who I am is family. My family means everything to me. I'm raising my 17-year-old daughter, Lourdes, and my 14-year-old son, Matias. We like to travel. STEM is near and dear to me, and especially for young women. Bringing ALS awareness, like my bio said, I lost my husband to ALS a year ago. I have a weird obsession with yarn and knit. I like to jog and DIY projects around the house. So that's, and the pictures, so that's in the healthy days, that's my family there. And then this past year, I took the kids to Hawaii. And then one of the most exciting projects of my career was actually working really closely with German engineers in actually designing and modifying a coordinate measuring machine that would go into a glove box. So it was going to go into a glove box that had an inert environment. So the machine had to withstand an inert environment. We had to be able to maintain the machine and utilize the machine and, you know, operate the machine inside of a glove box. So that's me there with the small team that I worked with. There were many others. It was Westlar, Germany. In this far, that was the first gantry CMM I had ever seen. That's me standing underneath it, looking at it. We don't build that big of parts to need that big of a machine at Lano. But I thought that machine was just unbelievably interesting, right? Okay, the next slide. So what do I do? So I'm in the field of manufacturing. I've always been hands-on. I was never going to be an engineer that was going to sit behind my desk. So my division, what we do is we support manufacturing, which is the making of articles using machinery, right? That's the definition. But both in support of R&D and we support production. So either way, when our customers come to us, and they are internal customers, we do have customers coming from different in the complex, asking us to manufacture certain components for them, but most of them are internal to Lano. Regardless of where they're at, if it's, you know, the mad scientist thinking up their next experiment, it all starts with a drawing or a solid model. And in that drawing is geometric dimensioning and tolerancing. And that allows us as manufacturers to say, okay, what's the size, the material, what features are important? it's a symbolic language that you have to understand if you're going to be in my field. For the more complex components, immediately we'll go into a DMAT situation, which is gathering of, all the minds for design of manufacturability and testing. So in my division, we have manufacturing engineers, we have metrology engineers and process engineers. And Megan kind of touched on what a process engineer does. Manufacturing engineer will go in and see what it's going to take to manufacture this, if we have the right tools, if we have to go procure another tool, and when I say a machine tool. And metrology engineers, we do applied metrology, but that's the science of measurement. So the pictures there kind of show you what happens. I talk about procurement because procurement is a big part of making sure that we're able to get stuff done, identify how big the raw material has to be. And when I look at the material, we specialize more in subtractive manufacturing, so taking away material for the final component. And mills, lathes, grinders, you see a wire EDM. We also do fabrication. So we have water jetting, laser cutters, welding, and forming. So once we identify how we're going to make this, a lot of times it goes straight to our CNC programmers. Our programmers go ahead and write the program that's going to go to the machinist so that they can machine this part. They verify the program through a simulation or verification software to make sure that we're not going to have a crash, hurt anybody, or destroy a machine or destroy a part. After that, it goes into the dimensional inspection area, and that's my area of expertise. Depending on what the drawing call out is, we'll decide if that's going to go on a CMM, if some of it's going to be more open setup, and then we also have optical comparators. And then if an R&D project goes into production, that's when process engineers will get involved, and they start really honing in on what the process is, documenting that process, monitoring that process improvements, all that good stuff. Yeah, we can go on. Okay, so my field. Oh, and just to let you guys know, those and Maria will be happy about this one. We have my lead metrology engineer is actually an electrical engineer because we have to work a lot with machine controllers. So a lot of these probing systems will have LVDT heads that really have to be tuned up right with the controller in order to get the measurements that we need back from them. But applied metrology, and I call it applied metrology because metrology, again, is the science of measurement, but most of the times when people think of a metrologist, they think about somebody that works in a standards lab, either at NIST, our National Institute of Science and Technology. So we send them all of our standards, like this large bar that I'm holding in the picture there. That goes off to NIST. NIST is able to look at the distance between the lugs. There's ceramic lugs within the center of that bar, and they give me a distance between those lugs to a very, very low uncertainty, and uncertainty that I couldn't achieve in my lab. They come to me, and then I'm able to test and calibrate my machines to those standards. Product acceptance at the laboratory is 4-to-1. Which means that our gauge has to be 4 times as accurate as the characteristic to be measured. So if you go back to that drawing, there was a flatness call out. I don't remember what it was, but let's say that the flatness is 20 microns. Our whole process has to be within 5 microns, so 4 times better than that call out. And I just give you an idea of what a micron is there. They're tiny. And people tease it, the people that I work with tease I'm always chasing microns, and I am. I'm always trying to get things better, reduce error, understand that when a customer comes in with a high fidelity component, when we hand it off to them, they have to be extremely confident when they go to assemble their parts that they're going to go together, that they're going to fit together. And we're the final word there to say, yeah, customer, everything's going to go together just exactly as you wanted it. Here you go. So that's where I'm at. Then my last slide, I just wanted to touch on something that we do that I think is really great. And this is our Lano Machinist Apprentice program. I know that we talk about STEM fields, and a lot of them are, you know, heavy into school and spending a lot of time in the classroom. So this program is a pipeline program that trains early career machinists. The whole thing is that you have to have a certificate of completion in machine tool technology, which is a 2-year program, and then you come into the lab as a student and you finish all your training at Lano while you're working and through this apprentice pipeline program, and you're able to actually secure a full-time position at the lab after you complete this program. And what I've noticed that this program does is it grows, these individuals grow in the field of machining, become some of the best in the world, you know, machining exotic materials, very, very challenging geometries. They also grow into the field of high precision inspection or metrology and come into my labs, and they're able to do an outstanding job there. Some of the best dimensional inspectors are machinists. I've also seen where they grow into the field of CNC CAD/CAM programming and start actually programming these machines for other machinists. And there's a handful, and there's one that I know went off to even be a division leader at one point that came in through the pipeline program, but they utilize Lano's tuition assistance program and go on to earn a degree in engineering, become some of the best manufacturing engineers that we have at Lano. I think that the people that know the hands-on, understand the challenges of what it takes to actually build something, really give a lot of thought into experimental design, you know, manufacturability, what it actually takes, because we can all draw something on paper. We all can't make something. So anyway, I left the YouTube link there if anyone wants to check it out. It says a little bit more about that program.
All right, great, thank you. Yeah, that seems like a really good opportunity for people interested in being a machinist. So
yeah, and
sorry, go ahead.
I was going to say, just this year, our incoming students, we have 2 females, which I'm very excited and proud about.
Awesome, thank you. Unfortunately, we're running out of time, but I'm gonna give a opportunity for one final question. Sorry about, I know I said you have Q&A at the end, and but let's see if is there one burning question?
I had a question if somebody doesn't have one. But it's like the most fascinating part about mechanical engineering to me is always what you've said, the fact that like we can all draw something, we can't all make something. Has there ever been a person that like shows you a drawing or like wants something made or measured or like made to a specific standard, and you've had to tell them, no, that's not like makeable or measurable or whatever it is?
Yeah, so quite often that those individuals are usually ones that want to understand what we can do and really take advice on, okay, instead of this dimension or this datum, let's do this. Instead of this material, let's think about this. So those DMAS are real important right off the bat for us to all get together and figure out how to, because most importantly, we want to meet our customers' needs. And we love heroics at my division. Man, if we can deliver a part that is very, very challenging, we're all very, very proud. But yes, there are times that we have to go back to the customer and ask if we could rethink a few dimensions or needs. And what's really important for the part to do what they want it to do.
All right, thank you. Do you ever use 3D printing? Or sorry.
Yeah, so those pictures, there was some additives. It's in its infancy in my division, but we do have some plastic printers, and then we just stood up an additive additive. Well, let's see. I think it's one for aluminum and one for stainless, and they're going to be separated to, avoid cross-contamination between the two. But yes, it is in its infancy. We really do specialize in, subtractive, high precision, low uncertainty dimensional inspection.
But other organizations at the lab, we rely on 3D printing very much. I just had an experiment, and last week we decided we wanted to add a piece of plastic with a very specific elliptical hole in the middle. And I was like, oh, gee, machining this is going to be a nightmare because it had to be very precise. And someone said, let's 3D print it. And that's what we did. So we were able, within 2 days, we were able to have a piece that had of plastic, of poly, that had an elliptical hole in the middle. One thing I want to bring up to the audience is that what we've seen is that an internship or a job is not a final destination. We often talk about DOE national labs. Reina talked about the machinist program. If you're close to another national lab, look around. There are many opportunities to further your education. And when you already have a job, you heard about the GEM program. The GEM program is US-wide. There are many opportunities. You need to look for them. Find a team like Maria and Megan said about, or Brittany, about find a team of supporters that are going to hold your hand and help you figure out things that sometimes you don't even know yourself where you're good at. You kind of focus, oh, I'm bad at math and that's it, right? I cannot do that. No. Listen to others, because very often they see the greatness in you more than sometimes yourself. So even if we mention Lano, it applies to many DOE labs. And, sometimes you think, oh, we hear that in New Mexico a lot. Oh, going to college is so expensive. It's going to take forever. And then, well, guess what? There are many ways to get your degree. It can be working and getting your degree, like Megan and others have shown. And you don't have to, to spend your parents' saving or to have a loan for life. You just figure out what's available to you. And I think we have some questions, Andrea, or some comments in the chat.
Yeah, I see comments. People interested in engineering. And I think that, like Anna was saying, and other speakers, explore. You don't have to lock yourself in right now, especially you're in high school. So, check things out and you might see what you like. There are, like Anna was saying, these opportunities and for scholarships where actually you get paid. Okay, well, I'm gonna wrap up. Thank you everyone for joining. You can follow us. We're on social media at Sage S Camp. I will type that in the chat. Oh, there it is. Thanks for the slide. We do Sage Live on the second Saturday of every month. We will not have one in December. So go enjoy the winter holidays and we'll be back in January. And if you can answer a short survey, help us make this even better. And thank you to our speakers, and thank you all for participating and asking such great questions. We will see you in January. Bye, everyone.
Thank you, ladies. Thank you all.
Thank you, Anna, for coordinating everything. Thank you, Andrea, great MC.
Thank you.
Yeah.
We stop the recording, ladies.
Oh, sure. Thank you.